Section 7.6 is on rational equations. So these shouldn't come as a great surprise. Basically, a rational equation is just an equation that involves one or more rational expressions. So we notice that if we said 1 divided by x equals 2, this is a rational expression, or a rational equation. And we notice that, how do we solve these? We generally have two ways of solving these. One is a little more informal but faster. One is a little more formal but a bit more accurate. So the informal way is to essentially just cross multiply. So method 1, cross multiply and solve. So in this case, if we're looking at 1 divided by x equals 2, we notice we imagine it as being 2 divided by 1. So that means we're going to get 1 times 1 equals x times 2, divide both sides by 2, and we find out that x equals 1/2. And we notice if we take 1 divided by the quantity 1/2, we're going to get 2. So that works out nicely. If we had something a little more exotic, like x minus 2 divided by x equals 3/4, we'll notice that sometimes we're not always going to get an integer answer. We're not always going to get a rational expression. So if we tried that first method again, we notice we cross multiply. We get 4x minus 8 equals 3x, just cross multiplying. So we divide both sides. Actually, we want to subtract 3x from both sides. So if we subtract 3x from both sides, we're going to get x minus 8 equals 0. And so we can add 8. X turns out to be 8. And we notice we can check. If we plug in 8 minus 2 divided by 8 is 6/8, which is indeed 3/4. Now, the more formal way of doing it, if we take that x minus 2 divided by x equals 3/4, method 2 is to rewrite setting a single rational expression equal to 0. So in this case, we would subtract 3/4 from both sides. We wind up getting x minus 2 divided by x minus 3/4 equals 0. Then we have to get a common denominator. We're going to get 4x minus 8 all divided by 4x minus 3x all divided by 4x equals 0. And so that's going to give us x minus 8 all divided by 4x equals 0. And then we notice that that'll only happen if x minus 8 equals 0. We notice that the 4x in the denominators will never give us a 0. So 4x in the denominator can never make the expression 0. So in general, the only thing the denominator is going to do for us is let us know if some value is not allowed. And so we'll see an example of that in just a minute. So if we looked at something like Will that one work? If we looked at something like x divided by x minus 3, let's just use x squared. If we use x squared divided by x minus 3 equals, that'll work, 9 divided by x minus 3. We notice this is technically a rational equation, so this is kind of an easy one. We notice that we have to be a little bit careful because we notice if we cross multiplied, we wind up getting, if all we do is cross multiply, so method 1, we would wind up getting x squared equals 9, and x would equal 3 or negative 3, which is fine, but you notice that if x equals 3, the denominator is 3 minus 3, which is 0, and so we have to discard x equals 3. And so you notice with method 1, we often have to check for domain restrictions. So in this case, we notice the 3 has to get kicked out. And so we notice that we only have one solution, x is negative 3. And we can check it. We notice 9 divided by negative 6 is equal to 9 divided by negative 6. Now if we use method 2 instead, we notice we would rewrite it as x squared divided by x minus 3 minus 9 divided by x minus 3 equals 0. We subtract that 9 divided by x minus 3 from both sides. And so now we can write that as x squared minus 9, x squared minus 9 divided by x minus 3 equals 0. We notice the x squared minus 9 is x minus 3, x plus 3, all divided by x minus 3. We notice that the x minus 3 times x plus 3, that's better. So we have the quantity x minus 3 times the quantity x plus 3, all divided by x minus 3. The x minus 3's divide out, and get erased. The x minus 3's divide out, and we just get x plus 3 equals 0, and so x has to be negative 3. And so doing it this way takes a little more time, but often shows us values that are going to be excluded from the domain anyway. And so you have to watch out for those. So if we try number 18 on page 543, we've got 2/7 minus 1 divided by x equals 2/3. And so we notice that what we're often going to want to do is, before we have two options. We could subtract 2/7 from both sides. Let's write that out better. If we subtract 2/7 from both sides, we proceed to get negative 1 divided by x equals, we can write that as 14/21 minus 6/21, just getting common denominators. So we get negative 1 divided by x equals 8/21. So now we could cross multiply. We get negative 21 equals 8x. Divide both sides by 8. And x is negative 21/8. So the x equals negative 21/8 works out adequately. You notice you should check your answer. You notice checking them is a little bit complicated. We'd have to write 2/7 minus 1 divided by negative 21/8 equals 2/7 plus 8/21 equals 6/21 plus 8/21 is 14/21 is 2/3. But you're not, should you check them? Yes. Will I be expecting you to check them only if the questions on an exam or specifically asks for it. Now, we should also look at another way we could approach this. We notice we can make our lives a little bit easier. We had the 2/7 minus 1 divided by x equals 2/3. Something that we can always do is multiply both sides by the least common denominator. So we could have multiplied both sides by 21. And the advantage of that is it becomes 42/7 is 6 minus, we can multiply by 21x. We wind up getting 6x minus 21 equals 14x. We can subtract 6x from both sides. We get negative 21 equals 8x. And then divide both sides by 8. We get the same, x equals negative 21/8. And so in general, as long as the value we're multiplying both sides by doesn't include a domain violation, a domain restriction, we can usually as long as the value we're multiplying both sides by doesn't include a domain violation, it's not going to cause any troubles. We can just multiply both sides by whatever the least common denominator is and turn it into a nice, neat polynomial equation. So if we look at something a little bit messier, we could try number 32. We have negative 5 divided by q plus 5 equals q divided by q plus 5 plus 2. And so now, if we use that same technique, we can multiply both sides by q plus 5. That has the advantage that we're going to get negative 5 equals q plus 2q plus 10. So the q divided by q plus 5 multiplied by q plus 5 just got rid of the denominator for us. We're just left with q. And then 2 times the quantity q plus 5 gives us 2q plus 10. So now we can subtract 10 from both sides. We get negative 15 equals 3q. Divide both sides by 3. And so we find out that negative 5 equals q. And so we see, again, the advantage of this is speed. The disadvantage is we notice that q equals negative 5. We get negative 5 divided by 0 equals negative 5 divided by 0 plus 2, which is going to be no solution. No solution. We can't divide by 0. So let's try one more that's just a little bit messier. We notice that we can always make these arbitrarily complicated. We're not going to see any that are really, really bad. So one that's probably more on the line of something you'd see in a Math 200 level class. You probably won't see it on any of your exams in this class. If you had y divided by y plus 6 equals negative 6 divided by y squared plus 7y plus 6 plus 2 divided by y plus 1, we notice that we're going to need to multiply. We have to factor everything. We notice that y squared plus 7y plus 6 factors as y plus 1, y plus 6. And so we notice that we can multiply both sides by y plus 1 and y plus 6. That means we're going to get y plus 1, y plus 6 divided by y plus 6 equals negative 6, y plus 1, y plus 6, all divided by y plus 1, y plus 6, plus 2, y plus 1, y plus 6, all divided by y plus 1. And so you notice we could have probably skipped the second step, but we notice we want to be careful that we're getting rid of the y plus 6's in the first term, the y plus 1 and the y plus 6 in the second term, and the y plus 1 in the third term. And so now that whole big equation becomes y squared plus y equals -6 plus 2y plus 12. And this should look familiar. We notice that we can, -6 plus 12 is 6. We can subtract 6 from both sides, subtract 2y. So we have -6 plus 12 is 6, so we subtract 6 from the right side and the left side. We wind up getting y squared minus y minus 6 equals 0. And now we can solve that by factoring. So it goes straight back to solving polynomial equations. And so we know that y equals 3 or -2. But we notice that we have to double check that that's not going to cause any domain issues. And it doesn't. So we can use both of those. But we do have to check. So if we had gotten y equals -6 or -1, we would have had to exclude those.